So this question asks us to express this in partial fractions, and the likelihood is that the answer that we get from part A is going to be very useful when we start to work through the rest of the question. Now this is going to split into A over V plus B over 25 minus V. If we put the right hand side on a common denominator, I will get this, which means they're sitting on the same denominators, so I can equate the numerators. So what I can now do is sub V equals to 25. That would make this term go to 0, and the equation I get is 1 is equal to BV, and also sub V equals 0. That means this term goes to 0, and I get that 1 is equal to 25 minus V. These are two simultaneous equations, and if you work them out, you get that A is equal to 1 over 25 and B is equal to 1 over 25. So our conclusion is that 1 over V 25 minus V is equal to 1 over 25 multiplied by 1 over V plus 1 over 25 minus V. And that's the answer to part A. So we're now being given a practical problem. The volume V in microliters is the volume of a plant cell T hours after the plant has been watered, and it's modelled by the differential equation here. The plant cell has an initial volume of 20 microliters, so that means that T is equal to 0 when V is equal to 20. And we've got to find, according to the model, the time taken in minutes for the volume of the plant cell to reach 24 microliters. Okay, so what we've got to do is first of all solve this differential equation. So the first thing we've got to do is separate the variables. So I can say that 1 over V 25 minus V dV is equal to 1 over 10 dt, and I'm now able to put in an integration sign, which will get us to an equation in V and T by integrating both sides. Well, this is where the result from the first part comes in useful, because this is exactly the integral we're asked to work out on the left hand side. So therefore I can say the integral now becomes, and I'm going to put 1 over 25 outside the integration, this is equal to 1 over V plus 1 over 25 minus V dV is equal the integration of 1 over 10 dt. A straightforward integral. So therefore I get 1 over 25, the integration of 1 over V is ln V, and this is ln 25 minus V, and because we've got to deal with the negative V and using the reverse chain rule, this has to be negative. And this is equal to the integration of this side, which is a 10th t. And we mustn't forget the constant of integration, c. So we now need to find c. And to do that, we can use the initial condition, which is here, that at time t equals 0, v equals 20. So we sub those values in. So therefore 1 over 25, this is ln 20 minus ln 5 equals, this term disappears, and this equals c. So therefore c is equal to, we can push these together into ln 20 divided by 5, so this is ln 4 divided by 25. So to fully answer part B, we've now got to substitute that V is equal to 24, and we need to solve for t. And I get 1 over 25 ln 24 minus ln 1 is equal to a 10th t plus our value here, ln 4 over 25. Ln 24 minus ln 1 is simply ln 24. So this is ln 24 over 25, and that equals a 10th t plus ln 4 over 25. Multiplying through by 25, The ln 4 comes over the other side, becomes negative, and again we can put those together to be ln 6. And cancelling a 5 out of this, I get 5 over 2t. So therefore I get t is equal to 0.717 hours. And this, if we convert this to minutes, this is equal to 43 minutes. And that's the answer to part B. So I've done some rearranging. I've removed the partial fractions part of the question and just left the result here. So we've now got to take our main equation here with the value of c and make v the subject. And to do that, we've just got to compress all this to one ln term on the left and everything else on the right. So the first thing I'm going to do again is multiply through by 25. So this goes, and I get 25 on the top there. So therefore I can put these two ln terms together into v over 25 minus v, and on the right hand side got 5 over 2t plus ln 4. So again we've got to keep putting these ln terms together. So therefore I've got ln v over 25 minus v. This will be another negative ln coming over, which means I have to divide this by a further 4. And that is equal to 5 over 2t. So at this point I can take antilogs. So I get v over 4 multiplied by 25 minus v is equal to e to the 5 over 2t. So therefore, multiplying across, I get that v is equal to 100 e to the 5 over 2t minus 4v e to the 5 over 2t. You've still got to put these two v terms together, so I get that v, 1 plus 4 e to the 5 over 2t, is equal to 100 e to the 5 over 2t. So going on, v is equal to 100 e to the 5 over 2t divided by 1 plus 4 e to the 5 over 2t. So if I divide every term by e to the 5 over 2t, I get 100 over e to the minus 5 over 2t plus 4. Now that does compare with what they've got, and I get that a is equal to 100 and b is equal to 4. And those eventually are the answers to part C. So with space virtually completely gone, part D suggests that there is an upper limit for the volume of this cell, and they've called it L. And we've asked to find the value of that and give a reason for the answer. Well, that's using this equation here. When t becomes massive, this term will effectively disappear, and we're left with 100 over 4. If t is very big, e to the minus 5 over 2t goes to 0. Therefore, v goes to L, which is equal to 100 over 4, which is equal to 25. And in a way, there's nothing more to say. The cell size reaches a limit, and it's 25. And that very squished in is the answer to part D, and the end of the question.